Last week, we talked about populations and samples. We talked about voluntary response. What's an example of a voluntary response? Like an online poll. Yep, exactly. And convenience samples. It's like, I need to get some data real quick. I go into Mr. Baker's classroom, and I survey everybody in there. It's just convenient. Or I survey the first 10 people that get to school in the morning. We talked about using a table of random digits. Remember that? Yeah. To select a simple random sample. What's a simple random sample? 800 students in the building. They all get a number. I randomly select 5 numbers or however many I want. Today we move on. We talk about stratified random samples and cluster samples. And then we talk about, well, what else can go wrong with sampling? Undercoverage, non-response, and the wording of questions, which are kind of self-explanatory. A stratified sample, here's where you gotta stick with me. I'll try and cruise through this quick. A lot of the information's up here already. There's not a ton to write, so we'll try and engage your mind as much as possible. This is a common alternative to an SRS. What we do is we classify the population into groups of similar individuals called strata. So your strata might be gender. Your strata might be your grade. You could have maybe by income. You can see on surveys, when you take a survey online, sometimes it's like which category do you fall in as far as your income level. So what happens here is we take our strata. I have males and I have females. And the males, I give them a number. The females, I give them a number. From the males, I'm going to maybe select 5 guys. And then I'm going to select 5 girls. And that way, I'm sure that I have 5 guys and 5 girls from my information. Whereas if you do a simple random sample and you're like, I want 10 people, it's possible you could get a group of all females rather than having that split. So we can sometimes give more precise information about a population than an SRS, but both sampling methods are hard to use when populations are large and spread out over a wide area. So even Northwest High School, it's like I want 5 males and I want 5 females to survey. If everybody has a number, and I give you, say, let's select 5 students, 5 males and 5 females, to go around and find number 002 and to find number 251, who has those numbers? It's a little hard to do. Cell phones only. A growing percentage of Americans are dropping their traditional landline phones and using their cell phones exclusively. This has caused a problem for polling organizations who in the past only used landlines when randomly selecting people for their polls. Since the group of people who use cell phones exclusively are different in many ways than people who do not rely exclusively on cell phones, who would likely be your people that use landlines still? Older people, right? So that's where they're taking the landlines, and now we're taking the people that have cell phones, and you're creating 2 strata. Why? Because those 2 groups of people are completely different. So I want a certain number from each of those, and then we're going to gather our results and compare and see what we have. Cluster sample. So this one was just like make you aware of that, just kind of an information for you. A cluster sample is selecting groups of individuals near each other. So it's like we go out, we select a group of individuals all near each other. So we divide the population into smaller groups. Clusters should mirror the characteristics of the population. So yes, I may go into a classroom and survey everybody, but that classroom that I select, ideally, I would have freshmen, sophomores, juniors, and seniors if that's who I'm trying to target for my population. And then choose an SRS if the clusters, all individuals in the chosen clusters are included. What is a cluster? We're going to look at it in this example. What we have here is an assembly at school. Describe how you would use the following sampling methods to select 80 students to complete a survey. So what do we have? Our 9th graders are sitting in seats 601 to 800, so it's like this back section. We have then the 12th graders up front in seats 1 to 200, so it's like your seniors, your juniors, your sophomores, and then your freshmen is what's happening in this auditorium. How do we use a simple random sample to select 80 students? What's a simple random sample do? The what? randomly draw numbers. You randomly draw 80 numbers. Everybody has a number and you randomly select 80 of them. So what do? Randomly select 80 students from 001 to 800. And the easiest way to select those students, how would you randomly generate 800 numbers? Or not 800 numbers, but 80 numbers. Using a calculator, maybe? No, we're not actually going to do it, but we could type in 00, we could type in 1, 800, and then we could say, 80 to select your 80 numbers. Stratified random sample. We're creating our strata. What would our strata be here? The grades, right? So we have 4 grades, so how many am I going to select from each grade? So that we can even them out. 20, right? So we randomly select 20 students from each grade. So 20 from 601 to 800, and this is dealing with our freshmen. 20 from 401 to 600. These are sophomores. 20 from 201 to 400. Those are your juniors, and then your seniors are 1 to 200. So you want to take a proportional amount from each of your strata. And this is just assuming that there's 200 sophomores, 200 juniors, and so on. A cluster sample, you want to take a cluster and you're going to survey everybody in it. But you want your cluster to be representative of the population. So how would we do a cluster with this? We want our cluster to include freshmen, sophomores, juniors, and seniors. If you think about the auditorium, you've got freshmen up front, then sophomores, then juniors, and seniors, right? So if I go through and I select all these people going all the way back, wouldn't that be a cluster? If you figure this out, there's going to be, what did I figure? This is the 20th, the 40th, and then it goes all the way to 800. There are 40 students in a column. The way it figures out, there's 20 students, like there's 20 rows that go all the way back to include all those students. So how would we get a good representative cluster? We could, I'm not going to go over there. With the cluster, we randomly select 2 columns and survey everyone in the group. So for the sake of convenience, simple random sample, you randomly select 80 numbers between 001 and 800, and then you're jumping clear across people throughout the auditorium to try and sample people. Is that convenient? No. Stratified random sample. Yes, I have like my freshmen up front in the first however many rows that is, but still to randomly select numbers here and there and do a simple random sample in each of those strata, that's still not very convenient. So with cluster, if I survey a whole column, I could even go in this column right here and say, hey, take a survey, pass it to the people all the way back to you. That's a quick way to get out all the surveys, and then everybody passes them up when they're done. Does that make sense? You get your freshmen, sophomores, juniors, and seniors. Inference for sampling. Why do we rely on random sampling? Because it eliminates bias. eliminate bias in selecting a sample. To eliminate bias in selecting a sample. So that's why we assign people numbers and we randomly select them. Or that's why we do a cluster sample and I'm like, I want this row. We just randomly select it. It's not because I'm choosing my friends, because they're sitting around me. The laws of probability allow trustworthy inference about the population. So just based on the way probability works, is it always going to be a completely random sample? Not always, but that's what happens with probabilities, that you get a pretty good representative sample based on your population. What can go wrong? Undercoverage. This is kind of self-explanatory, but what undercoverage is you're leaving people out. Some groups are left out of the process of choosing the sample. Under coverage, some groups are left out of the process of choosing the sample. So this is like going to the telephone book and you randomly select however many telephone numbers that you want and you call those people. Who am I leaving out of the survey? The people with cell phones, the unlisted numbers, right? Which is a lot of like younger people my age and your age. Non-response. This is when individuals are chosen for the survey or are chosen for a sample cannot be contacted. Or refuse to participate. Individuals are chosen for a sample, but they cannot be contacted or they refuse to participate. So sometimes when you guys start doing your sampling, your surveying, you're going to go into a class, you're going to say, hey, I want to survey everybody in here. There's some people who aren't going to want to participate, and that's okay. But that's in the end when we draw conclusions and stuff. We're like, we had a non-response rate of so many. We had a few people that just didn't choose to participate in our sample. Response bias. This is a systematic pattern of incorrect responses. Systematic pattern of incorrect responses. So you give somebody a survey. On one question they answer yes. On a question very, very similar to it, they answer no. Or you ask a question that asks them to come up with a number, and the number is just like totally bogus. And this would be response bias. And wording of questions, this is one of the most important influences. It's one of the most important influences on sample surveys. One of the most important influences on a sample survey. Why? Depending on how you have a question, it's really going to change all the results that you have. It's one of the most important influences on your sample surveys. And that's why before you guys go and you give all your surveys out, I want to make sure that we read through them and have people test them and we see where we're going with all this. 2 examples. We're getting closer to this up here. Women Love and Non-Response. In 1988, Sherry Hitt published a book entitled Women in Love, A Cultural Revolution in Progress, in which she claimed that 70% of women married 5 years or more are having extramarital affairs. Hitt's survey was sent to 100,000 women, and her conclusions were based on the 4,500 who responded. What was the non-response rate for the study, and how might this non-response rate have affected the results of the survey? What's the non-response rate? How many people didn't respond? that many people responded out of 100,000, right? So how do we find who didn't? Subtract. 100,000 minus 4,500 gives us 500. That's your non-response rate. It's huge, right? If you found that percent, that's just crazy. How might this non-response rate affect the results of the survey? Yeah, it's barely anybody that you have information from. And why would people not respond about that? They're guilty, they're ashamed, right? That's why you're not going to have people responding to that survey. People saying, did you have an extramarital affair? Who's going to admit to that, right? And this one as well, talking about wording of questions. During the middle of the drive to pass healthcare reform legislation in July 2010, several different polling organizations attempted to measure the sentiments of Americans. A New York Times CBS poll found that 66% supported a government-administered health insurance plan, something like the Medicare coverage that people 65 and older get. That's how they worded that question on the CBS New York Times poll. However, a Fox News poll found that only 44% supported a government-run health insurance plan. Same question, asked two different ways. And my main thing I want to draw your attention to, do you see how there's a difference in the way those two questions are worded? A government-run? Who wants to be a part of a government-run? Doesn't sound kind of like dictatorship. So like a government-administered health insurance plan versus a government-run, it's like, ooh, I don't know about a government-run plan. So you look at 66% versus the 44%, you're going to get strikingly different results. And to clean this up here, we have sampling errors and we have non-sampling errors. And these questions come up again and again. It'll ask you, is this a sampling error or is it a non-sampling error? And it's like, well, what are our options even? So a sampling error comes from the act of choosing the sample. And these first two, they're not necessarily sampling errors, they're just really biased. So these two are just really prone to bias. They're not necessarily errors, though. We know voluntary response samples and convenience samples, those have lots of bias. A random sampling error, it's just if you make a mistake when you're randomly selecting numbers. And under coverage, that's one of those things where it's like, this is totally your fault when you go out to do a survey. If you leave a group out of your survey, you say, I want to know about all Northwest High School students, but I intentionally or unintentionally, either way, I leave out like the sophomores, but I have information from freshmen, juniors, and seniors. That's under coverage. That's something you did. A non-sampling error, this is an error resulting from the participant or its survey writing. So a non-sampling error would be non-response. You give a survey to somebody, they don't respond, they don't take it seriously, they won't, not that they don't take it seriously, but they don't respond or you can't contact them. Response bias, people lie, make up stuff, you know it's definitely not right. And the wording of questions. Yes, wording of questions is your fault, but it's not in the act of doing this, in conducting the sample. It's part of your survey that's wrong. So it's not a sampling error, it's a non-sampling error because of your survey writing. You see it? Questions?